Hello everyone, come back to the TLBT channel. I insist you. And I just joined lines with that nonsense. Right, now we have Mercury, also named as a swift planet. It is the innermost and the smallest planet of the solar system. And it has no atmosphere to retain heat. This is where we go. Further explanation. So if you have a Mercury, it's like kind of a structure, not the Mercury you see nowadays, like the ones with the liquid structure. It's like a tungsten. No, it's not tungsten, something like that, but not that one. Not the one in the periodic table. The one in the solar system. So we have the Mercury. It's kind of a rocky structure, you see. It's like you have this first heat and the second heat. Like if I can infer from this graph, it is split. And now in this graph you see that the base point and the hypotenuse and the height. So like I'm trying to explain over here is this is the base point, okay? For example, this is the base point. Already I have included the graph, so no need. And why didn't you remind me of this? Okay, so you have the picture over here. This in case in the Cartesian plane, but no need Cartesian plane. Just draw a bar graph, right? And then you just draw, like a line, just straight line from 0 to 5 or something like that. It's on the x-axis, and on the y-axis, just put up, and then after that, just draw a hypotenuse. That's where we come. So when we have this first heat, it just retains the heat. It does not retain in this structure because this structure is it's just complicated. It is just what else? Oh yeah, shrinky, whatever. Now see, if we have an Earth image, the heat is overcoming it. I mean, like if you have that Earth, right? So like if you put more heat and more immense pressure on it, and it just eventually just falls down from the graph. But again, it finds a way to come back. But in the case of Mercury, if the heat is eventually dropping, yes, the word dropping, if the heat eventually drops to the point in which you cannot just infer, that is the base point in which it ends. The second base point, the first point here, the end point. And you can't just revive that. You can't revive the heat. Reviving is something that you can't just make the heat appear to life again. You have to add again another heat, but which is the other heat, external heat, not the internal heat, the external heat, and again the external heat, not the external heat. So that's what I'm trying to say. When the Mercury, the heat just drops down, we add another heat, but not that heat. And then again it will go down. And we add another heat, and then it just goes down. That's how the heat structure goes. But why is this? Why? Drop down in the comments below, and I'm going to infer from this graph. So what we're trying to say over here, the Mercury has no atmosphere. It's kind of it has atmosphere, but I'm not saying it does not have. It just has a little atmosphere in which already it's completely faded. Because once maybe it was a livable planet, but all since it just became a Venus structure, and from the Venus structure it just became a rock. So just an asteroid. Furthermore, scientists have been thinking that we should not call this as a planet, but we can call it as a planet because it has a similar features of a planet. So that's why. But there's only one dissatisfaction. That is, it's in a form of an asteroid or a meteor or whatever. It does not have the atmosphere we need it to be having. So it's like Venus has an atmosphere, but it's completely heat. It's like ignition temperature is very high or maybe low, so that it just evaporates continuously. It does not condense, it does not precipitate, it just evaporates continuously, further making the heat ignitable, more flammable, inflammable, whatever. So what I'm trying to see here is Mercury's surface experiences greatest temperature. Yes, that we know, but it just eventually goes down, so it just becomes cool. Again, it just comes down, it just becomes cool. So Mercury appears as a star from Earth, but due to its proximity, it is unable to be seen. It is unable to be seen from the from the Earth. it just appears as a star. It's just, you know why? Because the rock structure over here, look at this line. What do you see? This is so brighter than the one in the Venus, and it's so brighter than one of the star, than one in the neutron star. So that's what I'm trying to say over here. Right. Now over here, if we further continue, this looks like a morning or an evening star. It just looks like that because the point over here is like the one, the darkest, it cannot be seen, but once that are brightest, it's appearing as a star. And when it just revolves and revolves and revolves, it just also rotates, we see as a morning star or a night star. The night star is the one over here, and the morning star is the one over here. So you just name an A and a B. So this is a B and this is an A. So see the line, and then you will get that this is a type of a star in which you can feel the light in it. Okay, sorry, it's the evening and then the morning, because evening you'll see stars, right? So that's one. And now it is unable to be seen because of that, just sort of the light structure. Now Mercury is observed 2 to 3 times a year, maybe in Canada, because in Canada you can see, because in the hemispheres, the northern hemispheres and the southern hemispheres, you can see that. And now if I further move, right, sorry, so this is how Mercury looks like. See, if you just see from here and then it just goes further, then you will finally see this. Alright, just a second. Next. And what did it do with this computer? Oh no, wait. Where is it? Sorry, I think I have to press this one. Right. History of Mercury. How Mercury was born. Formation and evolution. Mercury, the smallest planet in the solar system, is believed to have formed approximately 4.5 billion years ago. It is thought to have originated from the same cloud of gas and dust from the sun. That's why you catch the point. Remember I told you about the graph? It just goes from the base point and then the hypotenuse? Yes. So if you further see here, but before that I have said something. Yeah. Because before it was livable, but now it just became like Venus, and then from that type of a Venus, it just eventually just evaporated, and down to that it just became kind of a Uranus, and then from Uranus, I think so, it just became a rocky structure, which is further called as a rock planet, something like that. Yes. So 4.5 billion years ago, it was similar to like this, but it was kind of the heat was there, the cells, the animals, and all of that, and it was formed after the destruction and all of that. It is thought to have originated from the same cloud of gas and dust that formed the sun, known as a solar nebula. You know the solar nebula? Yes, the sun over there. Because of the sun's heat, the heat particles just came to the Mercury and it just created life over there, just a little bit. And then their formation of Mercury. It is believed to have involved the accumulation of dust and gas particles in the solar nebula. Over time, this material began to dump together and form larger bodies like this. These are the larger bodies, just dumped together and just formed many circles. Over time, this, or shall I say, some spheres. Over time, this material began to dump together and form larger bodies, eventually leading to the creation of the planet we know today. The evolution of Mercury. Mercury's evolution has been shaped by a number of factors, including its proximity to the sun and its lack of a substantial atmosphere. Over time, the planet has undergone many significant geological processes, including volcanic activity and the formation of impact craters. All of these just formed in the evolution. Now, we move on. is Mercury so small? Why? 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 Okay, so if I would try to just explain over here, listen to this. Why is Mercury so small? A comparative study. It's just a case study. So Mercury is the smallest planet in the solar system with a diameter of just 4,880 kilometers. By comparison, Venus has a diameter of 12,104 kilometers, and Earth has a diameter of 12,742 kilometers. So why is Mercury so small? Why is it? Even though the size appears the same, and then the just has a diameter and everything, why is it small? Well, so why is Mercury so small? To answer that question, we need to compare the formation, the evolution structure of the planet in our solar system. Mercury formed from the same cloud of gas and dust that gave birth to the rest of the solar system. However, there is a point there. There's a challenge of it. There is a risky task. Now, it is believed that Mercury's formation was disrupted by a gravitational pull force. That is why it led to this type of a formation that had just shrink apart. It used to be like a Earth, but it just shrinked apart because of the immense and the heavy gravitational pull. Of Jupiter. Yes, we do know that Jupiter. See, I'll give you an example. If an asteroid is moving towards the Earth, then why is it not hitting on top of the Earth? There are many asteroids that can hit on top of the Earth. There are many asteroids actually. There are many asteroids behind Jupiter and they're coming towards Earth, but they're not hitting it. What's the point? That's so useless things to do from the asteroid. Why the asteroid is running away from the Earth and it's not just coming further? It's because due to the Jupiter's immense gravitational pull. Why is that? Because if we want to know, we have to go to the Jupiter planet, but I can just tell you in a short 2 sentences. First point, Jupiter is a big planet, we do know that, and due to it has just kind of rock craters and all of that. And due to that, due to the big structure, you see all those moons, you know the moons, right? All the moons, there are about 46, 56, 66, 75, 84, I don't know, but approximately, I'll just check out. And Jupiter, it has many moons. And due to that moons, it's like so close and so related. And due to that gravitational pull, it's making the Jupiter difficult to be livable. Because now the icy planets always start from the Jupiter. And then it ends to the Neptune. The Jupiter is the first icy planet ever formed to have a big structure, and that it has a great gravitational pull among all the icy planets. Among all the planets of our solar system, it has just a gravitational pull, immense, heavy, not just what you see every day. It's so much, so big that the Mercury size is just kind of expanded, contracted, and expanded, contracted. Finally, it just shrank and contracted. That's why it's believed it was disrupted by the gravitational pull of Jupiter. This disruption caused many of the smaller planormals, I think so it is, yes, planormals that would form Mercury to be ejected from the solar system or collide with other objects. That's why we see many asteroids just going to go see Mercury or something like that, and then it just collide with other objects. Basically, Mercury is kind of a planet. It can be collided with other objects like meteors or meteors or asteroid. Everything can be just ejected towards it, and due to the gravitational pull, susceptible gravitation, it just collides with that and it just forms Mercury. So that's why, as a result, Mercury was left with a smaller mass and diameter that it would have had otherwise. If it did not have been interrupted by the gravitational pull, it could have been big, it could have been small, it could have been the size of the Earth. We might not know what would have happened if that was not the case. So, if it was not the case, We have no idea. We'll have to study about that too. Now, proximity to the sun. Mercury's small size is also due in part to its proximity to the sun. There's another factor why it's small. Because it is so close to the sun, it experiences intense gravitational forces that cause it to lose mass over time. Now, if you have a sun and you just have a Mercury, the Mercury is fine. I mean, the sun is nearby to be close with the Mercury. I mean, sun is not going far, but sun is going near to the Mercury so that it will expand and will just collide with that. Now, Mercury is in a type of endangered species. Endangered species is a type of a species in which it will become extinct. That's what we say over here, endangered planet. Mercury is further becoming a planet in which it will be extinct in the future. We might not know that. So we can't protect that because it's just a nature's law. And this has to be over here, that due to its intense gravitational forces, it's just getting a little evaporated or something. It's little, because 1 centimeter by day, I think so, and that's why it loses mass over time. In addition, the intense heat and radiation from the sun can strip away Mercury's atmosphere and other materials, further reducing its mass. Okay. Now we move on to the Mercury's layers and properties, a comprehensive overview. Surface features, interior structure, and magnetic field. Let's start off with the surface features. It is heavily cratered like a moon, but it is not just kind of a satellite. Moon is a type of satellite, but it is not. So we can't consider it as a moon. I mean, it has a moon. So with unique features such as the Caloris Basin and the Rembrandt Basin, the planet also has scarps or cliffs. You know, if you were to be on Earth, right, and you just go to somewhere in place, and you go to some house or something, that you have a cliff. And in that cliff, you're unsteady, and you just have a jump point. It's just an unsteady point. Same way over here. There are scarps or cliffs that can be up to a mile high. It appears to be short over here, the crater. But when you just go over here, you'll be just a tiny particle. You'll be referred to as a tiny particle if you just come towards the Mercury. You won't be like how you are in the Earth. Your size may shrink to the Mercury. Your size may just shrink to the Mercury, thus leading to a mile crater. So we might not know that if that's the case or if that's not the case, but it is the case why it is referred to here. Now, interior structure. It has a large metallic core, making up about 85% of all the planet's radius. Now, if you just combine all the planets, it's not that effective, because over here it has a large metallic core, making about 85%. That's little a lot, right? Surrounding the rock core is a rocky mantle, and a thin crust covers the surface, just a thin layer of the crust. The core is believed to be partially molten. Molten is a rocky formation due to the, those lava, due to the magma and the lava. It just kind of molten, which generates a magnetic field around the planet. Now comes the magnetic field. Mercury has a weak magnetic field. Weak. I'm saying weak. But Jupiter, strong. That is why even Earth has a little bit weak magnetic field. It will soon become endangered too, and then it will become extinct. So, partially molten metallic core. The magnetic field is about 1% as strong as Earth's magnetic field. This is why I'm telling you that Earth and Mercury is kind of similar. And now just move on to the next slide. In simple words, we can say that similar in appearance to a moon with heavy cratering, that's a crust. Surface crust has the presence of numerous narrow ridges. And mantle. Mantle gets cooled and contracted after the crust has solidified. We already know that it is a rocky formation It might be cool, it might be hot, but it's not that hot. It's not that, it's cool, but it's not that hot. So trying to refer to it here is just when the crust had solidified from the liquid structure, it's just it's not a liquid, but it's kind of a paste. So in that, it just cooled down and they contracted, and the solid had been over there. Now, extreme high density present in the core, high density, extreme, and large iron core content. Large, I must say. Now we have the purpose of Mercury, its importance in the solar system. The innermost planet, as the closest planet to the Sun, Mercury has a unique role in our solar system. It is only slightly larger than Earth's moon and has no atmosphere, making it an important subject for scientific study. Now, exploring Mercury's formation. Scientists believe that Mercury formed from the same cloud of gas and dust particles that created the rest of the solar system. However, its close proximity to the Sun caused it to lose much of its original atmosphere that became the small rocky planet we know today. We've already read that in the previous slide. Now, what's it, Ernst? Okay, fine. That was not supposed to be just read, so no problem. Mercury's role in planetary science. Mercury's unique properties, it has unique properties, and proximity to the Sun make it a valuable subject for scientific study. Its lack of atmosphere provides a clear view of the surface and allows scientists to study its geological history and composition. Additionally, its orbit around the Sun provides insight into the dynamics of our solar system. Now, Mercury Encyclopedia in-depth exploration. I'm going to give you only 1 minute or 2 minutes, to thoroughly read the slide, and I'm just going to read only one line of each sentence, and I'm just going to elaborate it only in 2 or 3, not words, but kind of phrases I'm going to read out. Here's 2 minutes. You can pause the video and take 2 minutes. We'll come back. Now, Mercury Encyclopedia in-depth exploration. So first point, Mercury is the closest planet to the Sun. A fascination celestial body. It has intrigued astronomers and space enthusiasts for centuries. As this section, we will delve deeper into the history of formation, properties, and future of the enigmatic planet. Just move on to this. Mercury has a unique orbit, yes, and it has a unique rotation, yes, that sets it apart from other planets in the solar system. Now, one thing, Mercury's surface is heavily cratered, and that has a rocky landscape. The planet's geology is characterized by large impact of the most prominent features as Mercury, large impact craters, celestial things there, and then the numerous cracks and ridges. Now, third, the planet's magnetic field is also weaker than the Earth's, which means that it is so much susceptible to the solar wind and other space weather phenomena. Now, in just a brief, not even a brief, it's kind of phrase, we have the encyclopedia. What, sir? What? Yes, I'm just gonna finish it off now. Now, we have encyclopedia. Now, buckle up and just gonna have a seat here. Alright. Now, encyclopedia, equatorial diameter, 4,879, approximately 5,000 kilometers. And mean distance from Sun, 60 million kilometers. And solar orbit period, 90 days, approximately 100 days. That would mean about just 1 year. 1 year is not 1 year, sorry. It's about 2 months or 3 months. 2 to 3 months, it's 90 days approximately. Yes, it's correct. Now mass, 3.3 into 10 to the power of 33 kg. Now mass rotation, wait, mass is that much? Oh no, that's enhanced. Now rotation period, 60 days. 60 days, what? For this rotation period? Right. Now surface gravity, 3.7 million per second squared. And now we have surface temperature, 167 degrees Celsius. Doesn't make any sense, as it Ernst. Well then why did he employ me over here? Right. Now next we have the Mercury's proximity to the Sun, effects and consequences. Mercury is the closest planet to the Sun and as a result experiences some unique effects and consequences. Orbit and rotation, you all know that. Mercury's orbit is highly elliptical. What is that? Yeah, elliptical. This is learning English over here. So, Mercury's orbit is highly elliptical, meaning it is not a perfect circle. I'm perfect. Just written I'm perfect. Why would you want the advanced English over here? Now, this causes the planet to experience extreme temperature changes throughout its year. As its closest point to the Sun, temperatures can reach up to 800 degrees Fahrenheit, while at its farthest point, temperatures can drop to minus 290 degrees of Fahrenheit. Mercury has slow rotation, taking 59 days, just 60 Earth days to complete one rotation on its axis and 88 Earth days to complete one orbit around the Sun. Now we have the atmosphere, magnetosphere. What is a magnetosphere? Is it related to the atmosphere? It has a gravitational pull? Probably. Now, Mercury has a very thin atmosphere with a surface pressure that is only about 1 trillionth. That is the decimal place, okay, of Earth's surface pressure. This means that the planet has no protection from the solar wind, which is a stream of charged particles that flows from the Sun. As a result, Mercury has a weak magnetosphere. Magnetosphere is magnetic particles of the atmosphere, so we call it as magnetosphere. The magnetic particles and the gravitational field of the atmosphere that is not able to fully protect the planet from the solar wind. Now, geology and surface features. Mercury's proximity to the Sun also had an impact on its geology and surface features. The extreme temperature changes have caused the planet's surface to expand and contract, as I've already said, creating a network of cracks and ridges. Now, move on to the next. Mercury's eventual demise is the last slide. Now, furthermore, we can just simplify this. Predictions for Mercury's demise. Scientists predict that Mercury's eventual demise will be caused by the expansion of the Sun as red giant phase will enter as its first phase of the life cycle of the Sun. As the Sun expands, it will engulf Mercury and the other inner planets. And now, destroying them in the process. This is estimated to occur in about 5 billion years. Possibilities for Mercury's future. While the eventual demise of the Mercury is certain, but uncertain, but certain, but uncertain, but certain, but uncertain, you might not know, just say there. There are still many possibilities for its features, for its future and its features and all of that. Some scientists have proposed this kind of idea that we might use it for the future terraforming of Mercury, which would involve the process of transforming the planet's surface to make it habitable for humans. Well, that could be great, but there's a thing over here. I just told you that the graph indicates that the heat just dropped down, but that won't be sustainable for the humans. And even if it just kind of like changed due to the proposition of this terraform in Mercury, it needs it has just a high temperature because it's near to the Sun, and that too all the water can be evaporated. And even if you add more and more terraforming, it just can't be a livable planet. It's not that I'm trying to object the idea, but maybe it has certain chances of livable. And this is a highly speculative idea, but it's an interesting concept to consider. That's why I consider it a challenge. Now we end the slide and we end the show. But here's a quiz we're going to upload there, and not here. I mean the YouTube. My channel. We're going to upload the question, and then you have to answer that question. Right, Ernst? Yes. And make sure to subscribe to my channel, like my video, and never pause. That's it.